Section 5.1 has to do with bisectors, medians, and altitudes. Before we can really get into the information, we need to make sure we have a few definitions so that we understand what we're talking about. If we talk about a perpendicular bisector, it's a line or segment that passes through the middle or the midpoint of a line segment, like the side of a triangle, and is perpendicular to it. So if I find the middle here and I draw a line that hits it at a 90-degree angle, that is a perpendicular bisector. It bisects the line and it's perpendicular to that. Concurrent lines, another word that we need to know what they're talking about. It's when three or more lines intersect at a common point. So these lines would intersect at this point. That point right there is what's called the point of concurrency. So the point of concurrency is the point of intersection of concurrent lines. So the point of concurrency for those three lines is A. We're going to be studying in this particular section different points of concurrency. A circumcenter, an incenter, a centroid, an orthocenter, and we're going to look at theorems and problems concerning them, and then we're going to put each one of those on a coordinate plane. The very first one that we're going to talk about, the first type of points of concurrency, is the circumcenter. The circumcenter is a point of concurrency formed from segment bisectors. Now we just had a definition of what segment bisectors were. Segment bisectors are a line that is drawn from the middle of a line perpendicular to it. So if I wanted to find the circumcenter for this triangle, I've got to find the middle of each line, and then I have to draw lines that are perpendicular to it. So in other words, I have to draw the segment bisectors. And the point where these three lines cross, which looks like it would be right there, is what we would call the circumcenter of that triangle. The circumcenter theorem says the circumcenter of a triangle is equal distance from the vertices of that triangle. So in other words, this point right here is the same distance from that line, or that angle, and that angle. And all three of those would be congruent. Okay, so the point where they all cross is the point of concurrency called the circumcenter, and that point is equal distance from each of the three vertices. That's the circumcenter theorem. The incenter is a point of concurrency formed by angle bisectors. So rather than it being segment bisectors, these are lines that cut the angle exactly in half. Now these are a little bit harder to draw as far as getting them right. Okay, so I'm cutting the angles exactly in half. And that point where these all cross, that point right there should be a singular point, is called the incenter. An incenter, if it's drawn correctly, and of course we struggle with this because we're not on a coordinate plane and we're not absolutely measuring how to cut that exactly in half. That probably tends to go this way a little bit more. It is equal distance from each of the sides. So if I draw a perpendicular line to each of the sides, in theory, each of those are congruent. That's called the in-center theorem. A centroid is the point of concurrency formed from medians. Medians are lines drawn from the middle of the line to the opposite angle. So they're a lot like the circumcenter, but they're not perpendicular. So if I find the midpoint again of each of these sides, and I'm just trying to eyeball it here. So I'm looking for the middle point. Eventually what we're doing is we're putting this on a coordinate plane so we can be more exact. Okay, so I draw from the middle point to the opposite vertex, and that's known as the median of this. And where they cross is called the centroid. Okay, so the centroid is formed by drawing medians. So each one of these points of concurrency are a result of different drawings. One is the circumcenter is the segment bisector. The second one we did, which was the incenter, that's the angle bisector. This is the third one, and these are formed from the medians of the triangle. Okay, and this is a centroid. The centroid theorem says that the centroid of a triangle is located 2/3 of the distance from a vertex to the midpoint on the opposite side. So let's say I'm going to label these. And I will go ahead and label these X, Y, Z, and let's call this, I don't know, W. Okay, so what this theorem says is the distance from B to W, this part right here, is 2/3 of the entire distance, which would be BZ. So this, from the vertex to the centroid, is 2/3 of the whole distance of that line. So I could say CW is 2/3 of the distance from W to X, or C to X, sorry. And I could say AW is 2/3 of the distance from A to Y. And that would be the centroid theorem. Now we're going to do a few problems that have to do with this before we go on. So an example problem of this, it might tell you that points U, V, and W are midpoints of this line, and this line. And based on that centroid, now if you know that they're midpoints and they're drawn to the opposite vertex, you know that this point here in the center is what we call the centroid. So we are going to use the centroid theorem. So based on the centroid theorem that says from the vertex to the centroid is 2/3 of the whole distance, I can create equations. So starting at the vertex, I can say 3b plus 2 is 2/3 of the distance from here to here, which is 3b plus 2 plus 8.7. Okay, so then I have 3b plus 2 is equal to 2b plus, and then when I add those together, I'm going to have 10.7 that I'm going to multiply by 2/3, 10.7 times 2 divided by 3, and I'm going to have, that's going to be like 7.1, and the 3 is going to be repeating. Okay, I can subtract here, and I'm going to get a b on this side. I subtract the 2, and I find out that b is equal to approximately 5.13 repeating. So that would give me the b value. To find the a value, I might use this one right here because that's where the a is. So I start at the vertex, so 7.4 is 2/3 of 7.4 plus 2a. And that would be my equation for finding my a value. So I have 7.4 And then I'm going to go 2/3 times 7.4. And it's going to give me 4.93 repeating. And then I'm going to multiply here, which is going to give me 4/3 A. I'm going to subtract 7.4 minus the 4.93 repeating. Obviously that's going to be rounded there. And that's going to give me approximately 2.47. It's equal to 4/3 times A. So I'm going to divide that, the 2.47, by 4/3. Don't forget to put parentheses around your fractions when you're using them. So I have 1.8525. So that's going to be what A is equal to. And then the C, I'm going to have to use the fact that 15.2 is equal to 2/3 the total length, which would be 15.2 plus 5C. So I'm going to do distributive property there. And you can keep them as fractions or you can keep them as decimals. I'll go ahead and do this one as a fraction. Actually, no, I might not, because that's like 152/15. So we'll just call this 15.2 is equal to 10.13 plus 10/3 C. I'm going to subtract the 10.13. So I have 15.2 minus the 10.13. And I'm going to get 5.07 is equal to 10/3C. So I'm going to divide that by 10/3. And I'm going to get C is equal to 1.521. So that would be A, B, and C based on the centroid theorem. All right, the orthocenter is a point of concurrency that's formed by the altitudes of a triangle. The altitudes are drawn from the vertex perpendicular to the opposite side. So I start at the vertex and I draw a perpendicular line. Okay, so therefore it hits it at that 90-degree mark. Perpendicular on this side, and I'm just guessing here. It's going to hit it perpendicular, and then perpendicular on this side. So there is right there what you would call your orthocenter. It's a singular point. It's drawn or arrived through the altitudes, which are from the vertex perpendicular to the opposite side. Now we're going to turn around and we're going to put these on a coordinate plane. Now this is where it gets a little difficult. Okay, and these are the steps that we're going to go through. This is for finding the circumcenter. The very first thing I'm going to do is I'm going to draw the triangle and I'm going to sketch the segment bisectors. Now I've drawn the triangle over here. The problem that I would strongly encourage you to draw this bigger, because the bigger it is, the easier it is to see all this stuff. So I've got the triangle drawn. So now I want to draw the perpendicular segments. So I'm going to find the midpoint here, the midpoint here, and the midpoint here. And then what I'm looking for is the line that's perpendicular to those. And I'm looking for where they cross. So the problem with this is I've drawn my graph is kind of small, so it's hard to see. But I'm going to label this A, B, and C. Your graph does not have to be exact. In fact, you really don't even have to draw your graph, but it will help you picture what you're trying to find. So I need to find the slope of these points, and I need to find I need to find the location of A, B, and C, which are the midpoints. So hopefully you have the midpoint formula in your calculator, which will make things a whole lot easier. Let me grab a calculator that has that in it. Okay, so if I'm going to do the midpoint, this A is going to be the midpoint between the L and the J. So I'm going to put in -1, 0, and I'm going to put in 1, 3. And I'm going to get that A is located at 0, 1.5. So that is what A is. Then what B is going to be the midpoint between J and K. So I'm going to put in 1, 3, and I'm going to put in 2, -1, and it's going to give me 1.5, 1. Then I'm going to find C. So I need to put in -1, 0, and I need to put in 2, -1. And the location of C is 0.5 and -0.5. Okay, so these are all my midpoints. That's going to become important for 2 of these points of concurrency things that we're doing. Okay, we also need to find the slopes. Okay, so if you write them very carefully and it's very organized, then you can go back and look at them for other points of concurrency that you're trying to find. Most of the time they'll ask you to do the circumcenter, they'll ask you to do the centroid, and they'll ask you to do the orthocenter. The only one they won't ask you to do is not the incenter, because the incenter has to do with an angle. That's the angle bisector. So I want to find the slope of JK. I want to find the slope of KL. I want to find the slope of LJ. Hopefully you have the slope formula in your calculator, and so you can quickly do that. Now I don't have the slope formula in that calculator. Let me grab another one. Alright, so to get JK, I want to plug in 1, 3 and 2, -1, and it's going to give me a slope of -4. To do KL, I want to plug in 2, -1 and -1, 0, and that's going to give me -1/3. And then to do LJ, I want -1, 0 and 1, 3. Okay, and that's going to give me 3/2 as the slope. Once I have all that laid out, now I only really have to do that one time, and I can use it in different situations, but I want to find, and if I let the point of concurrency here be x, I want to find the equation for AX, which is that line that goes through there. It's a segment bisector. I want to find the equation for BX, and I want to find the equation for CX. Okay, now I really only have to do 2 out of 3 of those, but if I do all 3 of them, then I can know for sure that I'm correct. If I'm doing AX, then that means I want the equation of the line that goes through 0, 1.5, and is perpendicular to this. So that AX is perpendicular to JL. I come over here, LJ is 3/2, so the slope I'm interested in is -2/3. And I'll save the rest of that for a minute. This BX is going to go through the point B, which is 1.51, and it's going to be perpendicular to JK. JK is -4, so the slope I'm looking for is 1/4. CX is the point 0.5, -0.5, and it is going to be perpendicular to KL. KL is -1/3, so the slope I'm looking for is 3. All right, so now I have everything I need to come up with the equations. So that's the second thing. If I look at this, that's the second thing on my list, is coming up with the equations. So if you remember how to do that, you're going to plug in for your slope. Then you're going to plug in your y and your x. And then you're going to solve for your b, which is pretty easy on this one. And so your equation is y is equal to negative 2/3 x, there's my slope, plus 1.5. That's one equation. This one I'm going to do the same thing. So I have y is equal to 1/4 x plus b. I'm going to plug in my 1 for my y and my 1.5 for my x, and that's going to give me 0.375 plus b, and then I'm going to subtract 1 minus the 0.375. So b is going to give me a 0.625. Now, you're really not going to be graphing these, so you don't have to worry too much of going, oh, I don't know how I would graph that. Okay, I need the equation. So there's my second equation. Technically, I could get it with those two, but I'm going to do the third one. So y is equal to 3x plus b. Then I'll plug in negative 0.5. There's a lot to this, so be very careful you're not making careless mistakes, and we'll hope that we're not. So this is negative 0.5. This is going to be 1.5. And then when I subtract, I'm going to get negative 2 is equal to b. So I have y is equal to 3x plus negative 2. Now I want to go under y equals, and I want to put all three of those points in. So do them as fractions. So negative 2 divided by 3, x plus 1.5, don't forget the x. Okay, and then I want 1 divided by 4, or 0.25x, plus 0.625, and then I want 3x plus negative 2. Now, if I've done this correctly, when I graph them, it should cross at 1 point. All three of them should hit 1 point if I've done it correctly. Then I'm going to go second calculate, I'm going to go down to intersection, and I'm going to find that point where they cross. The point where they cross is 0.95 is the x, and 0.86 is the y. Now it's rounded off. This right here is the circumcenter. Okay, now that one's done. Okay, now I'm going to keep this page out here so that we can go back and refer to it. Because now they're asking me to find, on a coordinate plane, they want me to find the centroid. Now remember, the centroid is formed by the median, so the middle of the line to the opposite vertex. So the first thing I'm going to do is I'm going to draw those. So again, I've got the middle of my line, but this time they're drawn to the opposite vertex, and I don't have to worry about the angle at all. Okay, so I know and I'm going to go ahead and put my A, B's, and C's on there again. Same thing I just did. That's A, this is B, and this is C. Those are my midpoints. So again, and I've already found these, so I've already done all this work here. Okay, so I want to find, and again, we'll call that point of concurrency, we'll call that X. Now we're working on the centroid right now. So we want to find this line, and this line. So that is AK, okay, from here to here. I want to find JC or CJ, it doesn't matter which way you call it. And I want to find, I should have moved that out. We'll change that. We'll change it from C to J. And then we want to find from B to L. Now, in some ways, this one's easier than the last one because the point of A is 0, 1.5, and the point of K is 2, -1. So I'm going to use those two to find the slope. On C, I've got 0.5 and -0.5. My J value is 1, 3. And on BL, my B value is 1.5, 1. And my L value is -1, 0. So I'm going to find the slope using those 2 points. So I'm going to use the slope formula. Thank goodness for the calculator. 0 and 1.5 is 2 and -1. And it's going to give me a slope. Now at first this is going to look weird and you're not allowed to do it that way, but remember I'm just trying to find the slope. So I'll put that in a minute and we'll do it right now. 2.5 divided by -2 is going to give me a decimal. I'm going to go back and change it to a fraction. So this is equal to -5/4. Okay, then I'm going to do this one. So go back to the slope formula. And I'm going to get 0.5 and -0.5. And then 1 and 3. And I have -3.5 and -0.5. So again, I'm going to change that to make it proper. So I have 3.5 divided by 0.5, and it's going to give me a slope of 7. And then on this one, I've got the slope 1.51 and -1, 0, and it's going to give me a slope of 1 over 2.5. So again, I'm going to make it proper. So I go 1 divided by 2.5. It gives me a decimal that I have to convert to a fraction. So that's going to give me 2 over 5. And so now I have to go back and I have to find an equation for each one. So I can choose to use either set of points. So I have y is equal to -5/4 x plus b. And then I'm going to plug in -1 is equal to -5/4 times 2 plus b. So I'm going to solve for the b. So I have -1, and then it's going to be plus a 10 divided by 4, because that's going to give me -10/4 there. And it's going to give me b is equal to 3 over 2, or 1.5. So I'm going to have y is equal to -5/4 x plus 3 over 2. Then I'm going to turn around and do the same thing here. So y is equal to 7x plus b. I'm going to plug in the x and the y. And I'm going to find out b is equal to -4. So I have y is equal to 7x plus -4. Then on this one, I have y is equal to 2/5 x plus b. I'm going to plug in the 0 and the -1. And I find out that b is going to equal positive 2/5. So I have y is equal to 2/5 x plus 2 over 5. So I'm going to put all three of those into my calculator. and that would then turn around, and if I've done it correctly, they cross in 1 point. Now if they don't cross in 1 point, then you know something's wrong. So -5 divided by 4x plus 3 divided by 2 is 1, and then I'm going to put that one in, 7x plus -4, and then I'm going to put this one in, 2 divided by 5x plus 2 divided by 5, and then I'm going to graph it. And they do cross in 1 point. I'm going to go second calculate, then I'm going to go down, find the point of intersection, and it is going to cross. If you change it into a fraction, it's going to be 2/3, 2/3. And that right there is the centroid. All right, got one more to do, and that is finding the orthocenter. The orthocenter, remember, is the altitudes. So I'm going to draw the triangle and I'm going to sketch it, then I'm going to come up with the equations, I'm going to put the equation in, and I'm going to find the point of intersection. In some ways they're a lot alike, but they are found by different drawings. So you have segment bisectors, you have medians, and you have altitudes. This one, which is the orthocenter, is found by the altitudes. Now the altitudes are from the vertex perpendicular to the opposite side. So alright, so let's call that center point X. And so what we want to be able to do is we want to be able to use the slope. So what I'm looking for is I'm looking for I can do the slopes of these lines, which I've already found. So I'm going to rewrite it right here so I can pull them up. So I have JK is -4. I have KL, which is -1/3. And I have LJ, which is 3/2. Okay, so we needed all those. And so I am looking for these lines. I'm looking for LX, I'm looking for JX, and I am looking for KX. So that would be my third line. Alright, so what I'm going to do is I'm going to have to find, if I'm looking for JX, it is going to be perpendicular to the LK. Actually, let's start with the LX. LX is this line right here, and it is perpendicular. No, this is LX. LX right here is perpendicular to JK. So I am looking for a slope of 1/4. JX is perpendicular to LK. So I'm looking for a slope of 3. And then KX is perpendicular to JL, which is going to give me a -2/3. So those are the slopes that I'm looking for. So that's my slope, and then I need what L is going to be -1, 0. So that's going to be a point that it goes through since it's LX. JX is going to go through J, so it's going to go through 1, 3. And KX is going to go through the point 2, -1. So now I have to come up with those equations. So again, plug in the slope, then I'm going to plug in the X and the Y. Oops, that's positive. So I get 0 is equal to -1/4 plus b, so b is equal to 1/4. So this equation is y is equal to 1/4 x plus 1/4. So that's one equation. I guess I should have done that in pencil. Okay, then I have y is equal to 3x plus b. I'm going to plug in the 3 and the x, and I'm going to get b is equal to 0. So that's going to give me the equation y is equal to 3x. I can say plus 0, but I don't have to. And then this one, I have y is equal to negative 2/3 x plus b. I'm going to plug in my point, so negative 1 is equal to negative 2/3 times 2 plus b. So negative 1 is equal to negative 4/3 plus b. I'm going to add, I'm going to solve for the b. So I've got negative 1 plus 4 divided by 3. And it's going to give me b is equal to 1/3. So this is the equation. Y is equal to negative 2/3 x plus 1/3. Now I'm going to put all three of those into my calculator. So I have this one I'm putting in. And then this next one, and then I'm going to put that one in. I'm going to graph it. It should cross at one spot if I've done it correctly. And then I'm going to find the point of intersection. And that is going to give me that fact that the orthocenter is at 0.09 and 0.27. And those are rounded. Okay, so that's what you're looking for. All right, this stuff is tough. Your homework on this is page 243, 7 through 9 all, and 14 through 26 even.